last video we discussed sequential circuit. What is sequential circuit? Yes, sequential circuit is a combination circuit with memory. Clear? Okay. In this video, we are going to discuss some examples of sequential circuits. Flip-flops, counters, registers are some examples of sequential circuit. Okay. Then what is flip-flop? Flip-flop is a circuit with two stable states used to store binary data. Clear? Next one is counter. Do you know what is counter? Yes, counter is a circuit which is used for a counting pulse. Clear? Next one is register. Register is a type of memory used to quickly access, store and transferring data. Clear? Next, I am going to explain about SR flip-flop. Then do you know what is SR flip-flop? Yes, SR flip-flop is a sequential circuit used to store one bit of data. Clear? Then we can also say that this SR flip-flop is a bistable device with two inputs. Clear? Do you know why it is known as bistable device? Because it has two states. First one is set state and the second one is reset state. Clear? Next, I am going to explain the SR flip-flop with the diagram. Clear? With the circuit diagram. This is a circuit diagram of SR flip-flop. Okay, it has two inputs, that is S and R, and two outputs, that is Q and Q dash. Do you know what's the relation between Q and Q dash? Yes. If the value of Q is equal to 1, what will be the value of Q dash? It is equal to 0. If the value of Q is equal to 0, yes, definitely Q dash is equal to 1. Clear? And the next one is clock. Do you know what's the importance of clock in this diagram or in this flip-flop? Yes. The flip-flop, at each clock pulse, the sequential circuit changes output. Clear? Or we can say that when the clock is enabled, what happens? SR flip-flop will work. Clear? SR flip-flop has two inputs. What are them? S and R. If there is two input, how many combinations will be there? If it is two inputs, yes, that is 2 to the power of 2 is equal to 4. 4 combinations will be there. What are them? That is 0, 0, 0, 1, 1, 0 and 1, 1. Clear? That means either the value of S equal to 0 and R is equal to 0, or S equal to 0, R is equal to 1, or S equal to 1 and R is equal to 0. And the last one, S equal to 1 and R is equal to 1. Clear? These are the input combinations. Clear? Suppose the value of S is equal to 0 and R is equal to 1. This S equal to 0 and R is equal to 1. Here, what will be the value of clock? Yes, the clock enable means value is 1. Okay. Clear? Then this is AND gate, this is NOR gate. Clear? In the case of AND gate, if all the inputs are 1, output is 1. Otherwise, its output is 0. Clear? Here, the inputs are 1 and 0. So, definitely, its output is 0. Clear? Then here, both the inputs are 1. So, the output is 1. Clear? Then, in the case of NOR gate, if any of the input is 1, output is 0. Otherwise, its output is 1. Clear? If any of the input is 1, output is 0. Otherwise, it is 1. Clear? Okay. Now, you look at the board. Here, we cannot predict what will be the output. But here, we can predict. What's the reason? Yes. In the case of NOR gate, if any of the input is 1, output is 0. So, here the value of Q is equal to 0. Then, the Q will come here, the 0 will come here. then here all the inputs are 0. That means Q dash is 1. Clear? Q equal to here, Q equal to 0 and Q dash is equal to 1. Clear? Q is equal to 0 and Q dash is equal to 1. This state is known as the reset state. Clear? Reset state. Next, you suppose the value of S is equal to 1 and R is equal to 0. The value of S is equal to 1 and R is equal to 0. Then clock definitely it is 1. Clear? Okay. Then here this is AND gate. In the case of AND gate, if all the inputs are 1 means output is 1. Clear? Then here, yes, here all the inputs are not 1. So we can say that here the output is 0. Clear? Then in the case of NOR gate, if any of the input is 1, output is 0. Otherwise, its output is 1. Clear? So, here we can say that the output is 0. But here we can't predict. Clear? But this 0 will come here. Now, all the inputs are 0. So, we can say that here the value is 1. Okay. If the value of S is equal to 1 and R is equal to 0, what will be the value of Q? That is equal to 1 and the Q dash is equal to 0. Q is equal to 1 and Q dash is equal to 0. That means it is in the set state. Clear? Q is equal to 1 and Q dash equal to 0 means the flip-flop is in set state. Clear? Suppose the value of S is equal to 0 and R is equal to 0. In this case, what will be the output? Yes, here it is 0. What is the reason? Because in the case of AND gate, if all the inputs are 1, output is 1. Otherwise, it is 0. So, we can say that here the output is 0. Clear? Then, can you predict the output here? No. What is the reason? Because in the case of NOR gate, if any of the input is 1, output is 0. Here there is no 1, so we can't predict it. Clear? In this case, we will consider the previous state of this flip-flop, SR flip-flop. Clear? Then what was the previous state of this SR flip-flop? Yes, it is set state. Clear? That is Q is equal to 1 and Q dash is equal to 0. Clear? Okay. Then 0 will come here and 1 will come here. Clear? Okay. In the case of NOR gate, if any of the input 1 means output is 0. Otherwise, it is 1. From this, we can say that the SR flip-flop will not change its previous state when the value of S and R is equal to 0. Clear? S and R equal to 0 means, yes, a flip-flop is in the previous state. Okay. Next, you suppose both S and R is equal to 1. In this case, what will be the output here? Here it is 1 because in the case of AND gate, if all the inputs are 1, output is 1. Here, yes, definitely we can say that it is 1. Okay. Then, in the case of NOR gate, if any of the input is 1, yes, we can say that the output is 0. Clear? Then, yes, here also we can say that the output is 0. Look, here Q and Q dash is 0. Is this possible? No. It is wrong. Okay. So, this state is known as the invalid state and we will not consider this state. Clear? This is the truth table of SR flip-flop. From this, we can say that if the inputs are 0 and 0, what will be the output? It is Q0, Q0. That means its previous state or the value will not change. Clear? If the inputs are 0 and 1, that means S equal to 0 and R is equal to 1, what will be the output? Q is equal to 0 and Q dash equal to 1. Then we can say that yes, the flip-flop is in reset state. Clear? If S equal to 1 and R is equal to 0, what will be the output? It is Q is equal to 1 and Q dash is equal to 0. Then we can say that yes, SR flip-flop is in set state. Clear? If it is 1, 1, we can say that it is in invalid state. We will not bother about this input. Okay? Now I hope all of you understood SR flip-flop. Clear?